Thanks, Armen and David, for being here today.
Thank you.
And Armen was a very insightful talk. There's one very big question that everyone is asking: RAG versus large context models. What do you think is the future is going to look like?
My guess is that I think it depends on what scale of RAG you have. 100 million context link will land next year, and there's already nice tricks that you can do to get things really cheap. Like Anthropic has they're like KV caching API, right? So you can cut cost of having a very large kind of a prefix context by about 10x. That price will probably go down another 10, 20x by next year. So if you're at the scale of like, you're a small private company, maybe you have like 10 million, 15 million tokens, you probably don't need RAG, which is actually quite nice because you can focus all your efforts on building on a higher level of abstraction. If you're focusing on like all SEC filings, you probably still need RAG. I don't think 100 million will get you there. And I think multimodal is the other aspect or the other axis here. I think as you scale up modality, RAG just becomes necessary. There's just no way around it, at least in the foreseeable, let's say like 5 years.
David, you have seen so many technological waves, and given the experience you have, especially with Kubernetes and Kubeflow, etc., how do you see that? What are the similarities? What do you have seen with cloud technologies with what's happening today with AI?
Yeah, I think it's a really interesting question. Probably one of the biggest things is we're still at very much the hand-rolled phase. Everyone thinks that they are a unique special snowflake and that they have a stack which is wholly different than everyone else out there. And they spend a lot of time tuning it and so on and so forth. In each one of these ways with Kubernetes, with Kubeflow, with others, you got to a point where you really said, oh, actually, I can focus on other areas of my business that I actually provide unique value in. I'm going to take this other stack or this other solution that is pretty good, but flexible enough for me to build a layer on top of. And it takes time for people to realize that and get there. I'm not going to say that all of the tools are there for people to build on those stacks yet, but you do start to see directions around that kind of thing. And I think it's going to be really transformative when that becomes much more standard.
So you both have seen GPUs being used at distributed scale from 1,000 to 10,000 and maybe now getting into 100,000. Given the insights and the expertise you got, what do you think? How does every company going to build their own 100,000 GPU H100 cluster? Or there will be one single model that everyone is going to just use as over the API? What do you think how the future will look like? David, you want to go first?
Yeah, I'm definitely in the minority. Don't get me wrong. I love GPUs and the work that the accelerator community has done is just mind blowing. Don't follow my investment advice. I literally was scratching my head in 2012 of like, NVIDIA is like, surely someone else is going to come along and figure this out. Obviously, very, very, very wrong about that. But I do strongly believe, especially with the open source nature that we have today, you will see part of the transformation being there will be a common set of open source or flexible models, and then there will be a wave of fine tuning or quantization or things like that come along that allow inference to be run in much smaller, more compact, more specialized ways that don't require quite as much exotic accelerator in order to work properly.
Armen, what do you think?
Look, I think there's going to be a few companies that have the 100,000 plus clusters. Genuinely, I think if you look at the number of people that can actually operate at that scale, it's probably less than 200 or 300 people in the world.
Yeah.
So there's a fundamental human limitation to how many models can be put out. There is a fundamental question. I think what you're getting at is will closed source models stay at some fixed gap with open source, or will the gap continue to increase? And the truth is I don't know, right? There's not I look at what Meta's doing, and there's no game theoretic reason why this would happen. This is because Zuck wants to release models. Right?
Absolutely.
And tomorrow he might decide that the OpEx cost is too high and the models will stop being released.
Yeah.
And when you only have a single player that's really in the open source game, it's tough to justify that there's a resilience that gap will maintain and not just increase in the long term. I think the capability gaps are actually growing. I know in general the reaction to O1 wasn't that big, but it's an absolutely incredible model. Like I'll just say, like I have kind of no idea how it was done. I would be surprised if anyone outside of OpenAI knows how it was done. So the gap is growing, not just compute, but in terms of techniques as well.
Well, we thought you had all the insights. So another question you have is that you see the open source versus closed source game as you discussed as well. What do you think the AI regulation phase, like the role is on this game? Like we have US, California law that recently didn't pass. You have the Europe is heavily regulating AI. What do you think we should do in terms of the regulations?
I'm probably a little bit more in the minority here. I believe in, to some degree, stronger regulations, but in very specific ways, right? Like, a lot of this comes down to you have to observe what the impact to a given model is, or impact to a given service. So it's not, I don't know, to use a what do you call it example, it's actually not illegal for me to go and create a nuclear reactor in my backyard. I can actually go and do that. It's totally legal. People do it all the time. There are famous courses at MIT that teach you how to do this, so on and so forth. It's not at scale. If it goes wrong, very little bad happens. So on and so forth. The amount of radioactive material is de minimis. The problem is that when you start putting this into much larger scale, that means you, as a regulatory body, need to observe the amount of damage that can happen if something goes wrong. And so I don't feel there's necessarily something wrong with an organization saying, hey, look, if you're going to accept, I don't know, 1,000 requests a second, then you need to, obey this regulatory body or something along those lines. Now, again, that is not sophisticated enough to make a policy around, but I think there should be that kind of awareness about what the impact of these things are versus just saying, well, okay, you're not allowed to use whatever convolutional layers because those are the worst in the world. I have no idea.
Armen?
Yeah, I think the regulatory aspect is interesting. I think the way that this terms is like sovereign AI place, I think it's a much nicer way to say that, the US is so far ahead that Europe is very unlikely to win, as an example, right? So, or Japan for that sake, right? So what you see is companies that are foundation model companies that almost with I would bet my home that none of these Mistral or Sakana in Japan are going to ever catch up to OpenAI. And the consolidation of techniques will make it that, there's not going to be a French model and an English model. There will be a model. So what you see is, I think, for example, Europe being scared that, 50% of knowledge work will disappear and go to a US company. But the tech is moving in this way. So what you want to have regulations that make it so that money goes into the EU. And this is like what Mistral is, right? Is a sovereign AI play. Same thing with like Sakana in Japan. So I think from that perspective, it makes sense. I'm not big on the doomer side personally. I think humans will adapt to whatever models come out. But yeah, from the perspective of GDP going outside or inside your country, I think it's likely a very big deal.
You touch upon on your slides about how the Chinese researchers, they're using the latest KV cache results. I'm curious, what's your take on what's the R&D development between US and China, and how do you think that will apply on the large language model? You mentioned there will be a single model. What do you think? Will be a single model across the whole globe?
Yeah, I mean, this is tough, right? I mean, the core thing is that China is restricted in the amount of compute that it has, right? I mean, people do get H100s in China, but they're not building unified 100,000 H100 plus clusters. The opposite side of that is genuinely, I think the best research I've seen has come out of China. And for example, everyone here, I think will know Mistral or OpenAI models, but how many folks know the Qwen models or the DeepSeek models? I think those are as equally competitive as Mistral, if not better. So they're doing absolutely amazing research, and in some twist of irony, they're actually open sourcing everything. Which is kind of, the worry was always that, China would take these techniques from the US, but I think it's actually turning out to be quite opposite. But as long as they don't have compute, as long as they don't have the fabrication process to get large amounts of compute, I'm not seeing a way that techniques will get you, 100x, 1000x efficiency in your scaling laws. I just don't think that.
David, what's your take?
Yeah, I mean, I think that I totally agree with the point. The only thing I would add to what you said is, I'm old enough to remember that early versions of the Mac Power chip were outlawed for export. The PS2 was outlawed for export, and you're like, wow, we look at that now, that's crazy, and that was not that long ago, right? Like, you're absolutely right. It's just things are moving so fast that if I gave you a model that could train today and produce only 50% of the quality of the soda models, like 50% of the quality of the soda models today is so far ahead of where everyone was just 2 years ago that you're kind of like, all right, well, they're a little bit behind, but like, it's not the end of the world. And so you're absolutely right. Governments will go, they will restrict or accelerate their populations by giving them compute, but I think the advantage there is going to be pretty small. The real advantage is the brain power, right? Can you take them? Can you make them user-friendly? Can you adapt them? Can you apply them internally in an accelerated way? That's where things really start to take off. And also, again, comes back to the impact and what it actually does for your population.
We touched upon one of the key 3 bottlenecks of how to go for the next scale for AI. And one of them is building the energy. Can you tell more like what's the bottleneck now and where do you see like is there an upskilling for the energy that we're going to need for training the next foundational models?
I'm not an energy. I love energy. I follow it all the time and incredibly enthused about the energy transition that's going on. I think, I don't know, maybe this is where I'm the most optimistic. Like, I think in, 5 years time, we're basically going to have unlimited energy, like literally too cheap to meter. And it will be ubiquitous. I think there's this very interesting challenge, which is, how do I take that energy and actually apply it to compute? And that is a very, very hard problem. Cooling, racks and towers and actually making them available and making your clusters reliable and so on and so forth. These are deep distributed computing problems. I think that's probably way harder than getting access to power. But again, that I certainly could be wrong.
No, I completely agree with you. I think the very common theme now is to actually start building nuclear reactors next to the data centers. There's no way you can pull that much power from the grid. I think it's quite hard. I think Musk actually did it. I think currently he is pulling from the grid. But long term, I think you're going to see energy generation be side by side with the compute. And there's a couple of companies that are trying to do this in a very sustainable way. I think Crusoe is one of the leading companies. I think they're building the OpenAI cluster kind of publicly now. Yeah, to your point, the infra is actually really hard. I think one of the funniest stories we've had was, I think when we were training one of the original Chameleon models, it was in June of last year, and our data center was in Phoenix. And for some reason, we saw that for a couple of weeks, things were just failing, right? And so we spoke with the PyTorch teams, we spoke with our cloud provider, we spoke with our core infra teams, are we doing something dumb and sending up CUDA the wrong way? And it turns out, no, there was just a heat wave in Phoenix, and then we would get errors and things wouldn't work. So we actually on our dashboard would have the weather of Phoenix.
Amazing.
Right? And so these things are there's such a long tail of infra problems that need to be solved. And the question is who's fundamentally going to solve it? I think Mellanox with InfiniBand solved a lot of the previous connectivity problems of very large clusters. But beyond 100,000 H100s,
you asked a question at the beginning, what did you see before? This is, again, exactly what you said. If you go back to, call it 1999, 2000, one of the most innovative things that Google did was not, was invent, MapReduce, or whatever. It was a paper, obviously the concepts were out there, but they certainly implemented it at scale. They did it over very commodity machines at the time. And they were able to crawl much more quickly and produce results in a much faster way because this was a transformation at the software layer. That is something absolutely we're missing in ML right now. The ability to arbitrarily shard training and inference across commodity would be a tremendous breakthrough. I follow academia very, very quickly, and there is constant advancement around these things, but it's definitely not there because, the entire industry has been built up with the idea that I have an enormous amount of cross-sectional bandwidth between every one of my nodes in a cluster that allows me to do ring reduce or whatever's required for me to train that model. If we had a breakthrough that really sharded this out and made jobs far more embarrassingly parallel, that's where things really start to transform at an infrastructure level. But that is also a very, very hard problem. I'm not saying it's something you could just apply.
I think this is actually where Google shines very well with the vertical integration. Like, I remember speaking with a couple of like Google folks, and they'd be like, "Yeah, we would have like 1,000 CPU jobs we would forget about, and then come back in a month, and it would still be running." And I was like, I have no idea how that's possible. Like, our jobs die every 12 hours, and we have like a very complex restarting pipeline. And so I think the key thing that I think Google's still like, they're behind OpenAI, but not that far because they have this vertical stack. They have TPUs, they have JAX, they have XLA. NVIDIA has none of that, right? They have PyTorch, which Meta has done a great job, but it's not a vertical integration. But yeah.
It's funny. I was right here on this very stage 6 years ago announcing TPU support for PyTorch. And when I was working at Google at the time. And I still... It's an era where I really wish the two would come together a little bit more, collaborate a little bit more. I don't think there's that much value in these layers as an industry. Again, this is that classic XKCD where, congratulations, now you have 17 standards. But I wish people would focus on some other things because that layer, it's good enough for now. And I wish people would come together.
Well, thank you very much for this deep conversation, Armen, David. David, you're going to have a talk in a bit. And then we also will have Yangqing, one of the co-authors of PyTorch, who will hopefully give us some insights what happened from the other side. Thanks, everyone, for being here. I think we'll have a lunch and then we'll continue from there. Thanks, everyone. Oh, David now and then lunch. Yes, awesome. Thanks, everyone.